Hi guys, this is then 2.5. So we just completed 2.4 video on functions transformations, but it was more reflection, right? So this one is the last one. This is about the compression and the stretch. Now just be really careful. Stretches vertically is easy. However, horizontal way can be a little tricky, okay? Can be a little tricky. So be really careful with this and pay attention to this, okay? Now, let's take a look at the vertical stretch first. So again, the whole general form is y equals a f at b x minus c plus d. Now, some of you may ask me a question, Mr. O, your letters, the a, b, c, and d are not the same as what the textbook is showing. Well, it doesn't really matter whether they have to be the same letter or not in this case, because we're just putting the variables there to indicate that they may change, okay? So it doesn't really matter whether what you have inside of the brackets is H or K or P or R or S. It really doesn't matter. The whole purpose is that they are in the same format. Okay, so let's take a look at number 3. So this is actually about the stretch, but let's see whether it's going to stretch or compress. So if I have 2 f at x, well, by the way, we're still using the same graph from the previous lesson, which is the original graph. Now, the 2 times f at x means that it is 2 times f at negative 4 if the x is negative 4. Now remember, f at negative 4 was 1, so it'll be just 2. Same thing for f at, let's say, negative 2 for this case. Now f at negative 2 was 2, so it'll be 2 times 2, and that would be 4. Again, we're using this based on our original graph. Now then, if it is 2, then f at 1 then is, well, f at 1 was negative 4, so it will be negative 8. And lastly, f at 3, so 2 times f at 3. Now f at 3 was, I believe, 3, so 2 times 3 gives me 6. So this is now my new y values, and let's see whether with this existing x value and this new y values, we can come up with a new graph. So when x is at negative 4, my y is at 2, so it's right there. Now when my x is at negative 2, it is at 4, so it is right there. And 1, that gives me negative 8, so it's all the way down here, and then 3 gives me 6, so it gives me there. So if I connect the dots, okay, so I connected the dots. Now, okay, so hopefully you see that the graph actually stretched vertically, right? And it based up, I would just choose a different color for, let's say, the green. So in this case, from the green graph, it actually stretched both up and bottom. So I can see that what's happening here is, well, we can stretch the graph vertically. Now then, if we go to the next one, now this time it says 1/2 in the front. So it's basically, again, the same way, 1/2 then f at negative 4. Well, that is 1/2 times 1, which gives me 1/2. Then 1/2 times f at negative 2 gives me then 1/2 times 2, I believe. That gives me 1. 1/2 at f at 1 is then 1/2 times, what was that, negative 4, I think, and then negative 2. Then the last thing is 1/2 then f at 3. Then is then 1/2 times f at 3 was, I believe, 3, right? So this gives me, well, 1/2 times 3 is 3/2. So let's then draw our new graph with the existing x value with the new y values. So when f is at negative 4, it is at half. So I have to actually zoom in a little. So it's somewhere down here. And then when the next point, when it was 2, then it is at 1. Instead of negative 4, it's at negative 2. Instead of 3, it's at 2/3. So my graph now looks like this. Now, when you have this graph, as you can see, it is compressed, right? It is compressed. So it's kind of like squeezed from the top and the bottom by the compressor. So hopefully you can conclude this. If you have a number that is larger than, let's say, a 1 for the A value, regardless what the sign is. I don't care whether it's negative or positive. Again, the negative only affects whether it's being flipped or not. So in this case, we do not care whether it's negative or positive. Just look at the number only and see whether that is greater than 1. So in this case, it's 2, so it is greater than 1. That makes my graph, let's say, taller or stretched vertically. And if it was smaller than 1, let's say 1/2, then it compresses my graph like vertically as well. So then the conclusion for this part is then if the absolute value of A, which is the A value without any sign, is greater than 0, then it gives me vertical stretch. Now this is really important, vertical stretch by a factor of that A value. Okay, so if you look at this graph again, all the Y values actually became double, right? All the Y values have become double in this stretch. That's because it was 2. So obviously if it was 3, then all the Y values will be tripled. Now same thing over there. All the Y values are now halved. If it was, let's say, 1/10, then all the Y values will be 1/10 of whatever the original Y values, okay? So, but in this case, obviously, we do not say vertical stretch. We say vertical compression because we compress them, right? Vertical compression by a factor of, again, the A value. Whatever the A value, we basically just take it, okay? So remember, this is the proper terminology. Now, when you are writing a test or the quiz, in my class, without using these proper terminology, you're not going to get the full marks for that, okay? So just be really careful with the full terms. Now, if the A is a 0, well, if the A is a 0, it basically is a 0, don't you think? So if A is a 0, basically everything is a 0. It will actually become a line, but it's not going to be affecting anything, well, but making everything 0. Okay, so this one you can kind of ignore. If you really want to know, then think of this way. It will be if the f at x was y equals x squared, or let's say f at x was f at x was x squared, then if I change that to y equals 0 times f at x, that's basically 0 times x squared, which leads me to the 0, right? If I had f at x, then equals still x squared, but this time let's say it's x squared, and then I say what is then 0 f at x plus 1? Well, then this gives me 0 times x squared plus 1, which is 1. So this actually leads me into a horizontal line. Okay, it leads me to the horizontal line. So when a equals 0, this happens. Oh well, just food for thought. Okay, all right, so this is the vertical compression and stretch. Now I'm going to stop the video here, and I'm going to actually make another video for the horizontal compression and stretch. Okay, all right, bye guys.